Imagine peering into the very edge of the universe where time itself bends and the secrets of creation unfold. The James Webb Space Telescope, humanity's most powerful cosmic observatory, has just made a discovery that defies our understanding: a 13.8 billion-year-old colossal structure lurking in the depths of the early universe. Could this discovery rewrite the very laws of physics? Let's explore what this means for our understanding of space, time, and everything in between. NASA's James Webb Space Telescope, JWST, has detected an enormous structure stretching across billions of light years, existing at a time when the universe was barely forming. This discovery is astonishing because it shouldn't exist, at least not according to our current models of cosmic evolution. Scientists believe this structure could be a protocluster, a group of ancient galaxies bound by unseen gravitational forces. But the sheer size of this structure is baffling, spanning an unfathomable distance that challenges our understanding of how galaxies form and merge over cosmic time. This revelation adds to a growing list of cosmic anomalies that JWST is uncovering. If structures this massive existed so early in the universe, then our models of galaxy formation might be completely wrong. Could this be the key to unlocking a new era in astrophysics? Our standard model of cosmology, based on the Big Bang theory, suggests that after the birth of the universe, matter took hundreds of millions of years to clump together and form galaxies. However, what JWST has detected appears to contradict this idea. The structure is so massive that it should have taken billions of years to form, yet it appeared just a few hundred million years after the Big Bang. This suggests that something in our understanding of dark matter, gravity, or cosmic inflation might be missing. Could an unknown force be accelerating the formation of these structures? Or is our perception of cosmic time itself flawed? The deeper we look, the more we realize how much we don't know about the origins of the universe. If this structure is confirmed, it could mean our fundamental physics theories need a major revision. It could challenge the lambda cold dark matter (CDM) model, which is the leading framework explaining cosmic structure formation. Some scientists suggest that these findings could point to exotic physics, such as a previously unknown interaction between dark matter and normal matter. Others even speculate about alternative models of the universe, like the possibility that cosmic structures formed much faster than we ever thought possible. This discovery forces us to rethink not just how galaxies form, but whether our assumptions about dark matter, black holes, and even the nature of space-time itself are correct. An even more radical idea being discussed is whether this massive structure is evidence of something beyond our universe. Some physicists speculate that anomalies like this could hint at interactions between different universes, a concept known as the multiverse theory. What if this structure is a remnant of an older universe that existed before our own? Or what if it was created by unknown cosmic forces that don't adhere to our standard model of physics? The discovery opens up a Pandora's box of questions, pushing scientists to explore ideas once considered purely theoretical. Scientists are now using Webb to conduct deeper observations and gather more data on this mysterious structure. By analyzing the light signatures of the galaxies within it, they hope to determine its composition, motion, and age with even greater precision. Additionally, future telescopes like the Nancy Grace Roman Space Telescope and Einstein probe may help confirm whether these structures are common or just an anomaly. If more are found, it could signify that the universe is far more structured and interconnected than we ever imagined. One thing is certain, this discovery is just the beginning of a new era in astrophysics. The universe is revealing its secrets, and we're only scratching the surface. Dark matter is thought to be the invisible glue holding galaxies together, yet we still don't fully understand its nature. This newly discovered 13.8 billion-year-old structure may provide crucial insights into how dark matter shaped the early universe. One theory suggests that immense dark matter halos acted as scaffolding, pulling regular matter into place much faster than expected. But if that's the case, why haven't we seen similar large-scale structures forming so quickly elsewhere? By studying the gravitational effects within this structure, astronomers hope to confirm whether dark matter is behaving differently in the early universe. If discrepancies arise, it could mean we need a new model of physics, one where dark matter interacts with itself or normal matter in ways we never imagined. The universe isn't just a random scattering of galaxies, it's organized into an intricate cosmic web, with filaments of matter stretching across billions of light years. This massive structure could be an early segment of this web, hinting that the universe became interconnected much faster than expected. If JWST has detected a fully formed segment of the cosmic web at such an early epoch, it challenges our timeline of structure formation. Did gravity work differently back then? Or was there another unknown force shaping the cosmos at record speeds? This discovery could be our first glimpse at how the earliest galaxies fit into the vast cosmic blueprint that still defines our universe today. One of the biggest surprises in modern astronomy is how quickly supermassive black holes appeared after the Big Bang. Typically, they are believed to form over billions of years. But what if some of them emerged much faster? This colossal structure may harbor supermassive black holes that acted as seeds for rapid galaxy formation. If JWST confirms an unusually high number of black holes within this ancient region, it would suggest that they played a far greater role in shaping the early universe than previously thought. Could these early black holes have influenced the formation of this structure? Or did something even stranger, like primordial black holes from the Big Bang itself, help it take shape? Galaxies need fuel to form, and that fuel comes from enormous clouds of hydrogen and helium gas. But one of the biggest questions in cosmology is whether these gas clouds were evenly spread or clumped together due to unknown forces. The sheer size of this structure implies that immense gas reservoirs must have fed early galaxies, allowing them to grow faster than expected. But where did all this gas come from? If JWST finds evidence of unusually dense gas clouds in this region, it could indicate that matter wasn't as evenly distributed in the early universe as we thought. This would force scientists to reconsider how the first galaxies ignited and evolved. The Big Bang theory is the foundation of modern cosmology, but what if this discovery challenges some of its key assumptions? If galaxies formed faster than predicted, it could mean that our understanding of cosmic inflation, the rapid expansion that occurred moments after the Big Bang, is incomplete. Some physicists even speculate that the universe might have undergone multiple expansion phases rather than just one. Does this structure suggest that the universe is older than we think? Or are we missing an essential piece of the puzzle regarding how matter behaved in its earliest moments? Whenever a discovery challenges our understanding of the universe, physicists turn to new theories to explain the unknown. Could this massive structure be evidence of exotic physics? One radical idea suggests that new particles or forces influenced cosmic evolution. For example, some theories propose an early dark energy field that sped up structure formation in ways we haven't yet accounted for. JWST's discovery might not just expand our knowledge, it could introduce entirely new laws of physics that govern the cosmos in ways we never expected. If this structure truly dates back to 13.8 billion years, it may contain some of the very first stars ever formed. These population I stars were massive, short-lived, and made entirely of hydrogen and helium. No heavier elements existed yet. JWST's infrared sensors are perfectly equipped to detect the faint glow of these primordial stars. Finding them within this massive structure would confirm that galaxies formed much earlier than we thought. If population I stars existed in large numbers, it could mean that early star formation was far more efficient than current models predict. JWST is still in its early years of operation, yet it has already rewritten the textbooks multiple times. If this massive structure is just the beginning, what else could be lurking in the depths of the cosmos? Upcoming surveys may reveal even larger or older structures, pushing the boundaries of our understanding even further. We are entering an era of discovery that may completely transform how we view the universe. One of the reasons we can see this ancient structure at all is gravitational lensing, a phenomenon where massive cosmic objects bend and magnify light, acting like a natural telescope. JWST uses gravitational lensing to peer deeper into space than ever before. The discovery of this 13.8 billion-year-old structure may have only been possible because its light was amplified by massive intervening galaxies. Scientists are now using advanced simulations to determine whether gravitational lensing has altered our perception of the structure's true size. Could it be even bigger than we think? One of JWST's most powerful tools is spectroscopy, which allows scientists to determine the chemical makeup of distant objects. By analyzing the light from this ancient structure, researchers can find clues about the first elements created in the universe. If heavy elements like carbon, oxygen, and iron are already present, it would suggest that earlier generations of stars lived and died much faster than we expected. Alternatively, if the structure is still rich in hydrogen and helium, it may represent a pristine snapshot of the universe before complex elements formed. This could help answer one of the biggest questions in cosmology: how and when did the building blocks of life first appear? Astronomers are meticulous when verifying extraordinary claims, and some scientists wonder whether this structure is truly as massive as it seems. Could it be an illusion caused by overlapping galaxies at different distances? Or might we be misinterpreting data due to unforeseen instrumental effects? Researchers are now comparing JWST's findings with data from other telescopes, such as Hubble and the LMA, to rule out potential observational biases. If confirmed, this structure will stand as one of the greatest astrophysical discoveries of our time. One of the most exciting possibilities stemming from this discovery is its implications for extraterrestrial life. If galaxies and stars formed much earlier than we thought, then habitable planets could have existed billions of years before Earth. Did life have a head start in these ancient star systems? Could alien civilizations have emerged and vanished before our own planet was even born? Although JWST wasn't designed to detect extraterrestrial life directly, its findings push us to reconsider where and when we should search for it. JWST's discoveries are laying the groundwork for the next generation of telescopes. Missions like the Nancy Grace Roman Space Telescope, the Einstein Probe, and even ambitious concepts like the Louvre Space Telescope will take our understanding of the cosmos even further. These future observatories will provide sharper images, wider fields of view, and deeper infrared sensitivity, allowing us to confirm whether structures like this are common or rare in the early universe. We are witnessing the dawn of a new golden age of astronomy, where every discovery reshapes our perception of existence itself. Just a century ago, we thought the Milky Way was the entire universe. Now, we are peering back nearly 14 billion years and uncovering structures that defy our understanding. This discovery is a testament to human curiosity and ingenuity. It reminds us that no matter how much we learn, the universe always holds more surprises. What other hidden wonders await beyond the cosmic horizon? One of the most controversial ideas in cosmology is the theory of a cyclical universe, where the cosmos doesn't just expand infinitely, but instead undergoes repeated cycles of birth, expansion, contraction, and rebirth. If this massive structure existed so early, could it be a remnant of a previous universe? Some physicists suggest that cosmic anomalies like this might be leftover imprints from a time before the Big Bang, evidence that our universe is just one in an endless loop. If JWST finds more unexpectedly large structures in the early universe, it could lend credibility to the idea that the cosmos is far older than we've ever imagined. For decades, astronomers have estimated the observable universe to be about 93 billion light-years across. But what if the actual universe is far larger than we think? This 13.8 billion-year-old structure could be a hint that the universe extends well beyond our observable limits. If that's the case, then we may only be seeing a fraction of the cosmic web, with structures far more massive and ancient than previously thought. Could we one day detect regions of space older than the cosmic microwave background, a time before the universe became transparent? If so, our entire perception of the cosmos might need to be rewritten. Magnetic fields are one of the least understood forces in astrophysics, yet they may have played a critical role in shaping the early universe. Recent studies suggest that primordial magnetic fields could have influenced the way galaxies formed and merged in the universe's infancy. Could this massive structure be an example of magnetically driven galaxy formation? JWST's ability to analyze light polarization may provide insights into whether unseen magnetic forces helped sculpt the universe far earlier than previously believed. If the discovery of this massive structure doesn't fit within our current models of the universe, what happens next? Do physicists modify existing theories to accommodate the anomaly, or is it time for a paradigm shift? The history of science is full of revolutions, from Newtonian physics to Einstein's relativity to quantum mechanics. Could we be on the verge of the next great revolution in physics? Some theorists speculate that the entire CDM model, lambda-cold dark matter, may be flawed, and that new physics is required to explain what JWST is uncovering. If JWST has detected one unexpectedly massive structure, could there be more? Astronomers are now shifting their focus to other deep space surveys, analyzing whether similar galactic megastructures exist across different parts of the early universe.